this is a beautiful question here where we're going to practice on using the two formulas which are finding the area of a sector and finding the length of an arc in a sector. The question says that the length of the arc, so the length of the arc is given to us as 7.5 centimeter, and the area of the sector is given to us as 37.5 centimeter squared, and then they're asking for the unknown radius of this circle or of the sector and the angle of the sector. So we're going to write the general formulas of finding the area of a sector and the length of an arc in a sector as following. So area of a sector is angle of the sector over 360 times pi r squared. Let's give the angle of a sector as an unknown, the symbol theta. So we're going to say area of the sector is 37.5. So we're going to replace or substitute the area of the sector as 37.5 is equal to theta over 360 times pi r squared. If you look at this equation, there are two unknowns, theta and r squared. And I decided here to write one of the unknowns in terms of the other, meaning I'm going to make theta the subject, or you can choose making r the subject. This is totally up to you. We should end up with the exact same answer though. So in order to make theta the subject, we must get rid of the denominator by multiplying the whole equation by 360 as following. Don't calculate, just make theta the subject. So it's going to be 13,500 is equal to theta times pi times r squared. So the length of the arc, the formula of the length of the arc is equal to theta over 360, the angle of the sector over 360 times 2 pi r. The length of the arc is given to us as 7.5, so we're going to replace the length of the arc by 7.5 is equal to theta times 2 pi r over 360. So again, we have an equation with two unknowns, which are theta and r, and again, I'd like here to make theta the subject, while you can choose making r the subject. That's totally up to you. So if we're making theta the subject, we're going to apply opposite operation by first getting rid of the denominator by multiplying the whole equation by 360 as following. So it's going to be 2,700 is equal to 2 pi r. So if we carry on the left side, if we carry on making theta the subject, so we must isolate theta by dividing all or the whole equation by, we must divide it by pi times pi r squared. And in here, to make theta the subject, we must isolate theta by dividing all by 2 pi r. So we have two expressions for theta now. The first one is theta is equal to 13,500 over pi r squared, and the other expression is theta is equal to 2,700 over 2 pi r. Since this is, so we found the first expression from the area of the sector, and we found the second expression from the length of the arc of the sector. If we put the two expressions equal to each other, we're gonna end up with one equation, one unknown, which is r. So we must solve for r now, or we must make r the subject. The easiest way to do it is to cross multiply. How do you do that? You say 13,500 times 2 times pi times r, and then 2,700 times pi times r squared. So we're making r the subject, remember. So we're going to divide all by r. So if we divide all by r, so it's gonna be, the r on the left side is going to be cancelled. So, and we're going to have one r on the left side. So it's going to be 2,700 times pi times r is equal to 13,500 times 2 times pi. And we're making r the subject. So we're going to divide all by 2,700 multiplied by pi as following. So this way we isolated r, so r is going to be 10 centimeter. So since we found r, we can then substitute r in one of the expressions of theta in order to calculate the angle. So you're going to say the first expression states that theta is equal to 13,500 over pi r squared, and r we found it as 10. So it's going to be 13,500 over theta times 10 squared. Insert this in the calculator. So the answer will be correct to 3 significant figures as 43.0 degrees. And this is correct to 3 significant figures. If you substitute r in the second expression as 10 centimeter as well, so it's going to be 2,700 over 2 times pi times 10. And if you round this answer to 3 significant figures, it's going to be 43.0 degrees. So this tells us that both expressions are correct, and mostly the radius that we found is correct as well. So I'm gonna say please try to solve this question that we solved in this video on your own from A to Z without making any mistakes. And if you tend to make still make mistakes, please try to watch the video again until you master solving this problem completely on your own. And I'm gonna say at last, thank you so much for watching, sharing the link of this video, and for subscribing to my YouTube channel.